Have you ever looked up at the night sky, saw the moon and thought, where did it come from? Well, this answer isn't quite obvious. In fact, there have been several theories to account for the origin of the moon. But for now, we'll focus on the four main theories that you only need to worry about. The Capture hypothesis stated that the moon was formed in a different part of the solar system and was eventually captured by the Earth's gravitational pull. There is a little light in this theory. Since the moon and the Earth are composed of different materials and the moon lacks a significant iron core, the capture theory is able to account for this. On the other hand, the calculations show that if the moon came in range with the Earth, the two would have either collided or it would have altered the moon's path. Further objections to this theory include that a captured object orbits in a retrograde motion. That is, it orbits in the opposite direction to the rotation of the mother planet, such as Neptune's moon, Triton. We can also tell if a moon is captured if it has a non-spherical appearance, such as the moons of Mars, Phobos, and Deimos. And as we know, the moon orbits with the Earth and is spherical, which show that it is unlikely to be captured. So why don't we move on to the next theory? The condensation, or the co-formation hypothesis, states that the Earth and the moon were formed at the same time, at the same distance from the Sun and from the material in the solar nebula. Over time, the moon would begin to orbit the Earth and lead to the rotation we have today. This theory accounts for why the moon has identical oxygen isotope ratios to that of Earth, but of course, there are some problems. Analyses of lunar rocks reveal that the metal composition of the moon was very different to the Earth. The moon is metal poor, whereas the Earth is rich in metal. Also, it was revealed that the average density was different from that of the Earth, which suggests that the moon lacks a substantial iron core. These two pieces of evidence, therefore, imply they were not formed together. Another question you may ask is, why do the other rocky terrestrial planets, i.e. Mercury, Venus, and Mars, not have moons like ours? Why is it only Earth gets a moon formed in this way? And it seems this theory is unsustainable, so why don't we move on? The Fission Hypothesis stated that a young, rapidly spinning Earth caused a large chunk to spin off and form the moon. It was suggested that the Pacific Ocean basin were the remains of the event. This theory helps to explain why there is an iron core in the moon, but not a large one, and research has shown that the moon's composition resembles the Earth's mantle. It also explains what the others have failed to explain, the extra baking of the lunar surface. This is talking about how there are little volatile substances, such as water. But there is yet to be any concrete evidence for the Earth to have spun rapidly. The calculations show that no matter the speed of the Earth's rotation, this supposedly large chunk would either have stayed within the Earth due to friction, or the Earth would have hurled great amount of debris into space. It has also been proven that the Pacific Ocean crust is much younger than the moon, which disproves that the ocean basin is not the scar of the event. So let's see what the last theory has to offer. In 1984, a conference in Hawaii showed that the most favorable theory was the giant impact hypothesis, also known as the ejected ring theory and even the Big Whack. This theory states that the Earth collided with a Mars-sized planet, known as Theia, resulting in large volumes of material thrown out and creating a disk of orbiting material. Theia and a portion of the Earth melted and merged, while the orbiting material eventually coalesced and cooled to form our moon. This theory helps to account for a lot of aspects. Firstly, this theory helps to explain the lack of volatile substances such as water, as the amount of energy in such a collision would have vaporized them. The theory also helps to explain the lack of a significant iron core, as the collision was calculated to be off-center, and so the debris would mainly come from the outer layers. Also, this theory explains the different compositions of the two bodies, as some of the material of Theia ended up in the moon. As it was believed, Theia shared the same solar orbit as Earth. This would help to explain the identical oxygen isotopes in the moon rocks, as they were at the same distance from the Sun. Another piece of evidence was the discovery of creep-rich rocks in the ocean of storms and sea of showers. This basically means they contain potassium, rare earth elements, and phosphorus. Rocks like these must have required an ocean of magma for creep rocks to crystallize, and this would have been possible from the energy from this giant impact. This theory would also help to explain why the Earth is at a tilt causing the seasons. The idea is similar to that of Uranus. But despite the calculations and computer simulations, there is a possible flaw. Scientists reckon the debris spewed from the collision would have rained back down, and in order to form an orbit of debris, the impactor would have needed to be 3 times the size of Mars, even bigger than the Earth. Of course, there is ongoing research into the formation of the moon, but for now, the current theory that has been widely accepted is the giant impact hypothesis. Only time will tell until we find out where the moon really came from.